Okay, so as we go through this course, there will be times I'll just kind of stop and do like a little bit of a review or review one type of problem that you should know that will help us do problems in this class. And so one of those is rationalizing the numerator or denominator. So I just wanted to go through one quick example where we would do this to help us find limits. And so maybe we have in the numerator 3 minus the square root of x all over, I don't know, x, doesn't really matter, plus 3. And so if I want to rationalize the numerator, so I want to get rid of this radical in the numerator, what we do is we multiply by what I call a fancy 1. And that fancy 1 is going to help us get rid of this radical. We'll recall when you were looking at difference of squares, where you had a squared minus b squared. This factored as a minus b, a plus b. So technically what we're doing here is kind of going in the opposite direction. We know if we square a square root, that would go away. So if we can multiply by the conjugate of this and make it look like a difference of 2 squares, then it's going to get rid of that radical. So that's the whole point of multiplying by the conjugate. You might have heard that before, you should have. But the conjugate of this 2 terms is just changing the sign in between. Okay, so we're going to multiply it by our fancy 1 to get rid of that radical. And so doing that, we're multiplying by the conjugate, 3 plus square root of x. Whatever we multiply in the numerator, we have to also multiply in the denominator. And so when we're multiplying by the conjugate, actually don't worry about distributing the piece that didn't have the radical in it. So in our case, the numerator. So we're going to keep that in factored form, but the denominator. But the numerator in this case, we're going to distribute. And so let's do that. We can use this fact. We can either distribute out, always works, or use this fact that this is the same thing as the first term squared minus the second term squared. And if we do that, then we get 3 squared minus the square root of x quantity squared all over, and I'm going to keep it in this form of x plus 3 all times 3 plus square root of x. And so if I simplify this, I get 3 squared is 9 minus the square root of x squared is just x all over the denominator. And so we just got rid of the radicals in the numerator. We rationalize the numerator. Well, the only time we really want to do this is if we're taking limits and we get 0 over 0. So you might have a quotient and you might have a radical in the numerator. And if you just did direct substitution, it might have came out with not 0 over 0. We're only really going to do this rationalizing of the numerator denominator if we're looking at limits and we get 0 over 0. So let's look at an example of doing this with limits.